So in this video, we'll be explaining our technical demo of our senior Design2 project, in which we like to call Catch-21. Catch-21 was our idea to recreate the well-known game of Blackjack, which is often played by many casinos and events throughout the world. With this project, we wanted to make sure that it followed all the correct Blackjack rules, as well as being able to distribute a card to each player, the dealer itself, as well as keeping track of the dealer's score. With our idea of Catch-21, we wanted to make sure that it was both quiet, efficient, as well as stayed under our budget of $250. Also, throughout this video, we will go through some of the hardware and software of this project, as well as some of the constructions and more details of how the shuffler and other parts of the project work.
As you can see, this is our enclosure for all our wiring. It houses the Raspberry Pi and its GPIO expansion board. The two motor drivers, Team16 are there. They're silent, and that really adds to cutting down on the noise for our project, along with the shuffler relay that bridges that connection whenever the shuffler is told to run. Our 12-volt power supply also comes in through a port on the back, and all the wires escape through the front to go to our shuffling module. The USB webcam connects to one of the Raspberry Pi's three USB 3.0 ports. That allows for high frame rates and a decent resolution to be able to accurately see the contours of all the cards under the camera. The two stepper motors are wired to two TMC2208 stepper driver boards. These allow for precise control, and they both have 200 steps per revolution, which comes down to 1.8 degrees per step. So we can accurately determine where it's going to turn to reach each specific player, and we can also quickly change direction and speed if need be.
Alright, so a big part of this project was our motor driver boards, and we'll give you a little tour of the motor driver board here. As you can see, it has a plethora of pins, but I'll go through a couple of the ones that we used. This one is the actual motor driver board ground, and this one is the actual motor driver board power. This is from a 12-volt supply that comes from a wall outlet. Then you have your 2A, 2B, 1A, 1B. These control the actual coils of the stepper motors, and those are controlled by inputs from the Raspberry Pi and GPIO pins. Here you have the ground pin that is passed to the actual motor itself, and power that is actually passed to the motor itself. When we come over to this side, you can see up top here is a direction pin. When it is when it's logic high to this pin, so when there is power to this pin, the motor will turn in a clockwise direction. If there is no power to this pin, it'll turn in a counterclockwise direction. Here is the step pin. This is actually what controls the motor's movements here. So every time we have to send a signal to this pin to actually make it move. So it's basically like a clock clicking on and off and on and off and on and off. That's kind of how a stepper motor works. If you come all the way down here, this is the enable pin, which kind of basically makes this whole thing run. It has to be logic low, actually, so we have to drive this pin low to actually make this whole board work. So two other components I want to talk about this board here is the VREF capabilities. So we had to carefully calculate the reference voltage for this board so that we can make sure that we get the proper current to the motor so that they can spin accurately. So and the way we check that is through this little node right here. We can hook up a multimeter there and check the reference voltage, and then we adjust that with this potentiometer here. So we found out for our big motors, follow me here, for this motor here we needed a reference voltage of about 1 volt, and for this smaller motor here that actually spits out the cards, we needed a reference voltage of about 0.35 volts.
Alright, so we used a Python library called Tinker to develop a GUI for our project. If you look at the screen up here, it's usually on this lower screen, but for the sake of the video, we'll show you on a screen that's easier to look at. We have a layout that resembles the game board with the red, yellow, black, and blue buttons, along with a play button, reset button, and an exit button. So when you boot the game up, you will select which players you want. For example, red and yellow, and that's based on where you'll be sitting on the game board. To start the game right off the bat, you can hit the play button and the shuffling will begin and run through the entire software to play Blackjack. If you finish a hand and need to reshuffle the cards because you're out or because new players have come in, you can hit reset, and that will let the shuffler know that it needs to shuffle the next time the play button has been hit. Otherwise, if you just play a hand with like 2 players, for example, hitting the play button will skip the shuffling as long as there's still cards in the shuffle module. Finally, the exit button can be used to close the software if you're done, and that will allow you to unplug it safely without any corruption on the SD card. To automate the dealer's hand, we had to look into an image processing library known as OpenCV. It's an industry standard for computer vision processing. So it reads the cards by finding the edges on this green background, and then it pays attention to the ranks and the suits up in the corners rather than the image on the actual card, because that varies from deck to deck, and no matter what card you have, you always have the rank and the suit up in the corner, top left corner and bottom right corner. So when a card is placed under the camera, it's red and shows the suit and the number. For the game of Blackjack, we don't care about the suit of the cards, just the rank. So the first word of that string that pops up is written to a text file, and that text file stores the values and is read by both our Python program and C program to determine the value and sum of the cards in the dealer's hand.
So now we're going to show you an actual run through of the game. So the first thing you're going to do is split the deck in half and put it on either side of the shuffler here, and then you're going to decide which players want to play. You can play up to 4 players at any one of these colored buttons, but for simplicity reasons, we're just going to play at the black button and the yellow button. So we're going to come here to the GUI, or I'm going to select the black button and the yellow button, and then I'm going to press play. So right now the machine just shuffles the cards and it'll start to deal to the proper players. Now it'll deal it to the dealer, which I will keep this card hidden at the moment. And now it'll shuffle and give it to the players again. Now this dealer card, I'm actually going to show it. Okay, so now it is Black's turn. I'm going to flip his cards around, and he's got a jack and a 7, which means he has a total score of 17. Now, 17 is close to 21, but maybe I kind of want to be a little risky, so I'm going to ask for another card. And the dealer will give me an ace. So now, an ace is normally 11 or 1, but since 11 would bust me, I'm going to keep it as 1. So now I have a total score of 18, and I don't want to risk going over 21, so I'm going to pass my turn to the yellow button now. So it comes to the yellow button, and I'll flip his cards over. All right, he has a king and a 2, so that's 12. So I'm going to ask for another card, and it's going to give me a 6, and that also gives me an 18, which is a little bit too close for comfort. So I'm going to pass my turn to the dealer, and he's going to read the card that was previously flipped over, calculate its score, give me another one that's at 7, so it's going to add 9 to that, deal another card because it is under 17, and he's going to look at that king and realize, oh no, I busted, and show us the busted score, and that is how you play the game. So both players, yellow and black, won because they beat the dealer who busted on his hand.
Just one little quick thing that I wanted to mention as we go through some of the dispensing process. You can notice how the wheel that dispenses a card is going forward and backwards. That is to ensure that only one card gets dispensed, as we have had issues with multiple cards being dispensed. So some of the conflicts that we had came across when going throughout this design process in our project, we did notice that some of the angles that you can see here on our shuffler wasn't necessarily a necessity, but it did help distribute the cards to each player to make sure that they were able to reach the desired card. We also did have some scheduling conflicts with 2 of us working living out of town, it was kind of hard to manage having all of us here at the same location, but however, we was able to manage that and get through it. And as you can see, we did decide to use stepper motors for both the shuffler as well as the card dispensing system. We originally went with the idea of a DC motor. However, due to the limited range of motion and precision, we decided to go with a stepper motor over a DC.